Yes, yes, sir.
Deep breath means you are inhale the outside the air with positive energy. You feel like this, that energy flow through your brain, body, everything. That you are removing that air. Exhale means you have to exhale the through the mouth. That time all the negative energy flow through the your mouth. Same like you feeling. Just 5 times you do, then we will continue.
Okay, okay.
Okay. Thank. Okay, very much.
Okay.
Okay, sir.
Done, sir.
Done now. Okay, Gangu. Okay, thank you. Now, can you share my
Yes, yes,
Yes,
yes,
yes,
sir.
yes, yes, sir.
PPT as a PowerPoint?
Yes, yes.
Okay, this is
Yes, sir.
a paper 3, chapter 1.
Yes, sir.
So, PowerPoint, our
Anguli, how are you?
I'm good, sir.
Sir, okay, okay.
Sorry, Ganguly.
Okay,
Today,
okay.
my child also wake up quickly because my uh, doctor is getting fever.
Oh,
So, she also get wake up. My son also wake up quickly.
oh, how is he, sir? Now.
Fine, fine. Now, I want to take to Masudi.
Oh,
Uh, every day is both are wake up at 8 a.m. after 8 a.m. Okay. You know basic electrical system. What are the electrical system? Ganguly, can you hear my voice?
yes, 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 sir.
You understand basic electrical? What are the transformer, motor, transmission line, generator system? Do you know
Yes,
about
sir.
this?
Yes,
Okay.
sir.
Now it is a basic electrical system. This is a basic electrical from generation systems to end use. One one topic. And building. Already we know that house building, industry building, and what are the benefits, penalty, facility level, everything we will discuss this chapter. And the maximum demand, what are the benefit for maximum demand, reduce detection and the capacity bank, metering, load flow analysis, load factor, everything. And the power factor, importance of capacity selection, sizing, location, and automatic power factor controller, basic one. And basic transformer types and losses, and factors affecting distribution losses and improvement of options. And TNDFCC is standard labeling. If you are taking any equipment, Bureau of Energy Efficiency, they are giving the standard labeling on program. So that means every equipment have that prescribed label. That label should all detail mention maximum, how much energy, efficiency, or full load, off load, everything they detailed, all the details. And the same they will printed that completed detail also, and harmonics effect.
Okay, sir.
Okay, we'll see the main important topics. This generation, there is here a basic understanding only, where is coming from generation, power of the basic fuel, what are the fuel using, and power plant, the power plant to substation, power generation going on substation, substation to transmission line, HP, high, extra high HPL, then going to distribution system, distribution to customer end. Here one important point is basically we are using fossil fuels, coal, oil, natural gas, nuclear energy, uh, and falling hydel power plant. They were using for the power generation system. This is a basic understanding. There is no important point. One is important point is maximum 70% of power generation from thermal power plant of India. Do you know now this one? Almost we are seeing all power plant having that thermal power plant. Rest of this remaining is a renewable energy, hydel, and oil, gas power plant we are using. Maximum 70% is using. Right. Now one is a very very important point. Coal we are using. How to use coal is we are coaling. Uh, Coal is pulverized and is to the consistency of talcum. This is a very very important one mark. This one talcum powder. Can you hear this is one sentence?
Yes, yes.
Yes, sir. Yes.
Ah, yes, yes. This is very, very important. Important mark. One important mark. It is always asking what is the how the consistency of using the powder using means this is a talcum powder. They are using for the power generation and with the higher temperature 1300 temperature using, and this we are always using higher pressure steam used to spin steam turbine using. This is everything is thermal power plant.
Oh, oh,
Okay, and
yes.
basic concept, there is no important one mark. They are always put it everything is basic level to all the what are the system working, everything they put it in the books, everything basic level. Then we will consider the maximum important points. And here is one is important point is uh, our power plant everything is depends on the 28 to 35 efficiency. Efficiency is 28 to 30, very very important this one. Thermal power plant is a low efficiency, and this I always they are measuring this heat rate. What is the heat rate? Heat rate means is directly telling about this power plant efficiency. How is, suppose if the coal is coal 1 kg coal is 400 kcal, it is generating one, for example 1 kWh. Suppose one for generating 1 kWh we are using 600 kcal coal, then which one is efficiency high? Can you understand, Ganguly?
Yes, sir.
Yes,
One
sir.
is 86.
No, no, uh, this is I am telling example. One kg using for generating 1 kWh coal using.
Okay.
Suppose we are using 2 kg of coal for 1 kg, 1 kWh power generation, which is efficiency.
So can you please repeat it, sir?
Yes, 1 second, I will write it. One kg kale for 1 kWh. 2 kg coal, 1 kWh. 1 kg coal equal to 4,000 kcal. This is a 8,000 kcal. Which one is efficiency? Efficiency means output by
Output
input.
by input.
Okay. Which is a higher efficiency?
The 1 kg. First one, sir.
Yes, yes, yes. Same concept. This is one we are using. This is a heat rate always reflect the efficiency of power generation. It is
Yes, sir.
always we are always using heat rate. Very very important. And one we are this heat rate is converted to the heat input of kilocalorie. This is a unit. One is unit. This is a kcalorie or kilojoules. Always we are using that everything converted to kilocalorie. Otherwise kilojoules.
Yes, sir.
Totally. And power generator also 1 kilowatt hour. This is equal to that 860 kcal.
Yes, sir.
1 kilowatt hour equal to 860 kcal. 1 kilowatt equal to 860 kcal. And 860 kcal equal to 4,600. Sorry, 3,600
3,000. Okay.
kilojoule. That means 1 kcal equal to 4.167, sir, 187 kilojoule. This is very very formula. You have to muck up this one, important one. This is the unit value. Always they are asking this one. This base. This is a basic. This depends on we are calculating everything.
Okay, sir.
And basic transmission. What are the basic and lower the heat rate? Already we discussed. Lower the heat rate, higher the power efficiency. Do you understand this one? This concept? Okay, and this is formula same. Heat rate is inversely proportional to the this heat rate inversely proportional to the efficiency of power generation. Suppose heat rate increase, power generation is low, then is efficiency low. Then heat rate reduce, power generation high, then efficiency high. Okay, then transmission distribution line. Here basically basic understanding purpose. Say 50 cycle gets and 11 kV to 30 kV everything we are using for distribution line, and HP extra high voltage 200 to 400 kV. And what is the use of minimum the losses? Then substation network 130 kV 110 60 kV, and distribution 11 kV 6.5 3.3 kV, the basic one. And what is the use of same reduce the losses, and economic wire can be employed to carry the low current. Basic concept is reduce the wire reducing, then current carrying capacity reduce, then losses reduce for high voltage. What is the purpose of use high voltage? Reducing the transmission losses, power losses. The system is basic. Here there is no important point. Same, there is no difference between transmission line. Transmission line means basically is a higher voltage. Higher voltage means low losses. In distribution line, reducing that higher voltage to lower voltage. Then same concept, but losses increase because current carrying capacity increase. This concept you understand? Okay. And voltage gap in directly related to the line conductor resistance and reactance, and carrying the total number of length, total length and current driven by the lower voltage, the higher current. Higher voltage is a lower current.
Okay.
current directly traveled by inversely proportional to the voltage level. Same
Yes,
repeated
sir.
this one. Says current inversely proportional to the voltage.
Okay.
Power losses means I square R. This is a basic formula. And a higher voltage transmission and distribution are same. Minimum is the what is the use based on higher voltage increase the distribution losses. Then we increase the lower voltage to higher voltage. Then we will reduce the distribution losses. In so that the basic concept they are using very important one mark. This is a distribution. If suppose if distribution level is a voltage increase, then voltage drop is 1/3. That means 11 kV to 33 kV. Distribution 11 kV to 33 kV, because now it's a basic you understand is now you are using 11 kV, losses are high, then you increase the 33 kV, then losses going to reduce. How much the time? Voltage loss 1/3. Just you remember, yes, 11 by 33, so 1/3. This is a voltage level. Power mean you can know I square R, then 1/3 square, so 1/9. Power losses reduce. Okay,
Yes, sir.
can you see this clearly? This is my table also. This stuff up to this one basically you understand na, everything.
Yes, yes, sir.
Next, cascade efficiency. Basically cascade efficiency is from where after generation, then substation. You know the after generation have the substation. After this transmission to the higher voltage level transmission line, then going on, they need to calculate the cascade efficiency. What is the efficiency? They give all the details. It's a efficiency range. Generation, you know, 28 to 35. Substation level is 99.5%. Suppose there are still 0.5% losses, then you have to write it 99.5%. Understand this one? Extra high voltage 99%. All efficiency they are giving. What is the cascade efficiency you want to calculate? Then multiply everything. Generation to end user. Generation end user means don't include the generation from substation to. It's a cascade. Suppose they ask the cascade efficiency, transmission and distribution, then you include transmission and distribution here. They always ask in transmission distribution only. Then you use one transmission line. Don't include a substation. Suppose they ask cascade efficiency from generation to end user, then include all everything.
Oh, okay, sir.
Okay, na? Do you
Yes,
understand na?
sir.
This one? Did you understand? It's a efficiency means all multiplication.
Yes, yes.
All multiplication. This is main important problem. They will ask 1 mark only. This one. Here you see the they are told transmission distribution network end user these losses of efficiency. Then they multiply everything from um,
Generation to
99.995. 99% means 99 divided by 100. 99.5 means divided by 100, and everything multiplication is 87%. Our India has the 83% efficiency. Transmission line, transmission distribution, 70% is losses. This approximately now increase 70 to 50%.
oh, yes, sir.
Okay, na? Up to this, you understand this one, all the concept.
Yes, sir.
One is a basic introduction from power generation. What are the fuel using, power plant, substation, they generates the power from power plant and it's going to substation and transmission line, then another substation. There depends on the distance they change. Then going to power line, power line higher voltage level, extra high voltage, then going to distribution line, then going to customer. This is basic one. Then we are using what are the basic generation using coal, oil, natural gas, nuclear they are using, and cogeneration power line, solar energy, renewable energy we are using. And then it's a 70% power generation, basic and the thermal power plant in India. This is a coal-fired power generation we are using, and very very important one is one mark is coal is pulverized to the consistency of talcum powder. This is very very important. One mark this one. It's a higher voltage. We are coal firing. Everything is a 1,300 temperature, and the higher pressure steam used for spin the steam turbine. Higher pressure steam turbine we are using.
Yes, sir.
Okay, then we are this is efficiency 28 to 35 is. It's basically we are terms we are using heat rate is always telling about this generations efficiency, power generation efficiency, how much heat rate using. We are basically using the heat rate is a basic one. So it is very very important unit. So this always you write it note heat rate. What is the heat rate? Heat rate increase means power generation is reduce, universal proportional. So heat rate less, power generation is increase, then is a higher efficiency. And 1 kilowatt hour electrical energy, how much thermal energy means you have to write it 860 kcalorie of thermal energy. Otherwise 3600 kilojoules thermal energy. Very very important this one. Then transmission distribution line. It's a basic, it's a high voltage substations, what are the level they are using. Here is no info important, but here is a very very important losses. Suppose voltage increase, then losses reduce. Basic information is a voltage reduce, current down, current higher, so then is a losses increase. And voltage increase, current reduce, losses low. And distribution level always they are using the low voltage, then current drawing capacity high, so losses high. And what are the factors is always every time they are asking one mark. Suppose distribution level change to 11 kV to 33 kV, how much voltage loss we can reduce? So 1 by 3 times here losses, voltage losses. And power losses 1 by 3 whole square. Okay, then cascade efficiency from power generation to total end user up to. Suppose they are asking generation to end user, then you call it full. Suppose they are ask only transmission line, you don't include generation, remaining only take. Okay.
Yes, sir.